Good day, folks. So today we're back again to solve some problems regarding higher order linear differential equations. So we have this problem: y double prime plus 2y prime plus 2y is equals to e raised to negative x times cosine x. So we're going to use y is equals to e raised to mx, and we'll set the equation to 0 so as to find the auxiliary equation in order to get the roots for our complementary solution of the problem. So now we have y is equals to mx. Then we're going to differentiate it twice because the highest degree of the problem is 2, as you can see. And then we're going to form the auxiliary equation. So from here, we're going to factor e raised to mx to get this. Then by quadratic equation, as you could recall, which is negative b plus minus square root of b squared minus 4ac over 2a. So by inspection, our a is 1, b is 2, and c is 2. So doing the math here, we'd get 2 squared minus 4 times 1, 2 over 2. Further simplification would give us m1, which is negative 1 plus I, and m2, which is equals to negative 1 minus I. So, since the roots consist of a real number and an imaginary number, this is case 3, where alpha is the real part of the root, which is 1. The coefficient is what we're going to consider, and then our beta here is the coefficient of our imaginary root, which is also 1. So, by that, we could deduce definitely that this is of the case 3 of the format of our complementary solution of y is equals to negative x quantity c1 cosine beta x plus c2 sine beta x. So substituting the values of alpha and beta, rather this is alpha x, I'm sorry. So now we have e raised to negative x. Since our alpha is negative 1, let me correct that, and then c1 cosine x plus c2 sine x. From here, so our tentative yp now is e raised to negative x, a cosine of x, plus x e raised to negative x, b sine of x. Since we're looking for our particular solution, and specifically this concerns undetermined coefficients, so we'd set our c1 to a and our c2 to b for convenient purposes. So now we'd solve yp negative x a cosine x. So I'm just going to rewrite this so that it will be easier for us to differentiate this later, because we're gonna, again, in solving for the particular solution, we're gonna substitute this in the original problem, which is this. So let's differentiate this twice also. So our first differentiation would result to a raised to negative x cosine x minus a raised e to the negative x cosine x minus a e raised to negative x sine x plus b e raised to negative x cosine x plus b e raised to negative x sine x, and then minus b e raised to negative x sine x. So second order differentiation would result to negative a x cosine x plus a cosine x quantity negative 2 e raised to negative x plus e raised to negative x minus 2a e to negative x, so it's quantity here, minus e raised to negative x times x sine x, then plus 2b cosine x e raised to negative x minus e raised to negative x times x minus b e raised to negative x sine x plus b negative 2 e negative x plus e raised to negative x times sine of x. So we recall our problem, which is y double prime plus 2y prime plus 2y is equals to e raised to negative x cosine of x, so as to ensure that our particular solution is correct. So by substitution of our yp double prime and yp prime to the values of y prime, y double prime, and y respectively, we'd come up with this. And eventually, simplifying this, so this and this one, as well as this one, 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 would cancel out to give us a result by further simplification, which is raised to negative x cosine x minus 2a e raised to negative x sine x is equals to e negative x cosine x. Now, getting the coefficients of e to the x cosine x, we get 2b is equals to 1 and negative 2a is equals to 0. Hence, our b is equals to 1/2 and our a is equals to 0. Now, we go back to our particular solution and we substitute the value of a and b to give us our yp, which is equal to 1/2 e to the x sine x plus 0, the quantity of e to the negative x cosine x, and this would just cancel out, so our particular solution is just 1/2 e to the negative x sine x, and since our complete solution is just our is complete, is just our complementary solution plus our particular solution, hence our final answer is c1 e to the negative x cosine x plus c2 e to the negative x sine x plus this yp, which is 1/2 e to the negative x sine x. So this is our final answer. This is the complete solution of the problem.